Okay, folks, today's topic is graphs of polar equations. So our learning target, by the end of today's notes, we should be able to use some form of technology, either our graphing calculator or Desmos on the computer to make sketches of graphs of polar equations. So last time we talked about the polar coordinate graphing system. So instead of based on x and y, the polar coordinate graphing system is based on r and theta, which is some radius away from the origin and some rotation around the unit circle. I want to make a note right off the bat. I'm not going to be super picky about your graphs, but I am going to be looking for the intercepts, that the intercepts are all correct and that the general shape is correct. So the note I want you to, the note is you must include all intercepts. All right, so let's start off by getting our calculator. You can't really do these by hand. I don't know. I mean, once you see the pattern, you can start to figure them out. But before you know how the pattern works, it's really tough to do without a calc. So I want to make sure that my calculator is set up in the right situation. So if I go to y equals, I'm going to use my grapher. I'm going to go to y equals. Unfortunately, my equation isn't y equals, it's r equals. So I have to adjust the mode. So in here, we want to go to our mode. Anytime you do anything trig related, you have to decide which mode you should be in. So here's the rule of thumb. If you want to do something on this screen, like let's say you want to do sine inverse of 0.5 or 1/2, right? So that's going to spit back an answer that's in radian mode. Now, I don't know what that number is in radians. Remember, sine inverse of 1/2 is like pi over, well, we know what it is. It's pi over 6. But if you change your mode here to degrees, and I do that same thing, I just hit enter, it gives us the 30 degrees or the pi over 6. So 30 degrees and that's pi over 6 are the same thing. So on this screen, you want to make sure that your mode is in radians, or sorry, in degrees. Whenever you graph, you always want your calculator to be in radian mode. All right, so the other problem was from here I hit y equals, and I get to y equals. I want it to say r equals, so I'm going to go back to my mode. I'm going to go down here, and I'm going to change this to POL, or polar coordinates. Polar coordinates. And then when I hit y equals, now they say r equals. All right, so then I would type in the equation, but I want to set up the Desmos first. So let me set up Desmos before we, oops. Where am I? There we go. All right, so if you don't have your graphing calculator and you need to use Desmos, so over here, this little wrench thing is your settings. So we want to go in here. Your grid, you want it on, but you want to change it from a normal grid to the polar grid. So there's all of our circles. I like to include the axis. I like to go from, for our purposes, pretty much 6 is pretty good. 6 is about as far as you need to go. Yeah, okay, and then over here is where you're going to type in your equations. So let's say that we had, well, we know all the equations are going to be r equals, so we could put r equals in there, and then you would type your equation. Now what's kind of weird about this is you have to get the theta symbol. Well, I'll talk about that in a second. Let's go back to the, I think it's easier to do on the graphing calcs. All right, so here we are. I'm now in r equals. I can start to type in my equation, 2 sine of, now the theta button, once you change the mode, when you hit theta, that's why they list all these letters on here. Once you change the mode and you hit this button, now it makes a theta instead of an x. If you go back to rectangular mode, or function mode, it'll turn it back into an x. So I'm going to check my window. I'm going to do the same thing that I did here. Don't mess with these for now. This is just 0 to 2 pi. And then this is how often it draws a picture. I'm going to go from -6 to 6, just like we did on the Desmos, -6 to 6. And now I'm going to hit graph. So here's our picture. Now, you already noticed the notes. This is supposed to make a circle. It kind of looks more like an oval or an ellipse. So that's because of the way that, I don't know why TI did this, but they designed their screen as a rectangle instead of a square. So you can go in, if you're okay with it, you can leave it. But if you go into zoom, Remember, we always do zoom standard to get us back to the normal window. Well, right above that is zoom square. And what that does when you select that is it takes your picture and it makes it, or takes your window, I'm sorry, and makes that into a square. So it does extend this a little bit, but at least your picture now looks like a circle. So a couple of things that we want to talk about. Well, let's go to Desmos and try that as well. So here I am in Desmos. Now I'm going to type in 2 sine, and then unfortunately I have to type the word theta, T-H-E-T-A, to get the theta symbol. I don't know if there's a better way to do it, but this is the only way I know how to do it. And I always make these from 0 to 2, and you have to type the word pi, 2 pi. All right, and there we go. We now have a circle that looks again kind of like an ellipse. So I'm going to go back into my settings, and I'm going to do the same thing that I did on my graphing calculator, but for the Desmos window. You'll see underneath this option that we have zoom square. So when I select that, now this definitely looks like a circle. So it extended our window a little bit. I'm going to leave the X. I want the Y to stay as -6, so I'm going to change this. -6 to 6, and now I'm going to do a zoom square, and so that way we can still see all of the 6's in both directions, because all of my graphs in our notes and homework only go to 6. Alright, so I'm going to go back to the calculator. So let's talk about some of the characteristics. So if you look over here, there's some notes and some characteristics of the circle based on the equation. So our first equation was 2 sine of theta. Let's look at what happens when we change this from 2 sine of theta. Remember what this graph looked like? To 2 cosine of theta. You can just watch if you don't want to type it in. What happened? Yet again, we have that same picture. We have that same circle, but now that circle's on the x-axis. So when we're in sine, same picture, but it's on the y-axis. When we change that to cosine, it jumps to the x-axis, which makes sense, right? When we think back to our trig days, cosine and x were the same, and then sine and y were the same when it came to evaluating triangles in the unit circle. Now let's talk about some of the characteristics of the diameter and the reflection of our graph. So let's see what happens. I'm going to turn this back into sine so it's on the y-axis. Let's see what happens when I change this from 2. There's the graph. I change it to 4. Now, my circle is now going this far. Do a zoom 6. Oops, sorry. Now look at how far I messed it all up. Hold on a sec, guys. There we go. Okay, so now look at what happened to my diameter. Notice it's not the radius. Radius is from the middle to the edge. What happened to my diameter? So when the equation was 4 sine of theta, I had a diameter of 1, 2, 3, 4. When I changed that to 6, 1, 2, 3, 4, 5, 6. When I change this to 3, okay, now I'm going to change it to 3 in cosine. That's going to make it go a diameter of 3 on the x-axis, and there's our circle right there. So now I'm going to go back to my notes and leave myself a little reminder. The diameter, so the equations are a cosine of theta, a sine of theta. So it's whatever this value is what's going to tell me what my diameter is. So whatever that number is out front, that's going to give me my diameter. So let's now finally make a sketch of this thing. So it's going to be a circle, diameter of 2, that's going to be occurring on the y-axis. So yet again, I want to identify my intercepts. Let's start here. And then I'm going to go up to here, or diameter of 2, and then I'm going to do my best to make a sketch. Not my best circle, but not too bad. Okay, what's going to happen when we have this changes to a -4 cosine? You could probably already guess, but let's just double check on our calc. So now I'm going to change this to -4 cosine of theta. We graph it, and your instincts were probably correct. We have a radius of 1, 2, 3, 4, but that's going on the negative x-axis. Cosine is x. Since it's negative, it's going to be on the negative side. So now I want to make a sketch of that. I have one intercept at the origin, 1, 2, 3, 1 at the negative x side, and I'm going to try to draw a circle. What do you think? So far, so good? Okay, well, I'm going to pause us here and move on to the next ones. I don't have enough time left.